So in this particular segment, we are going to understand the concept of substitution of variables to simplify some simultaneous linear equations. This particular method is very much effective when you see variables in the denominator. So for example, let's consider that the equation is 6 upon x plus 8 upon y is equal to 4, and 3 upon x minus 4 upon y is equal to 0. Okay, so these are the two equations that I want to solve, and I'm solving for values of x and y. I immediately notice that x is in the denominator, y is also in the denominator, but nevertheless it is still possible to solve these set of equations, and I will show you a couple of methods to solve these set of simultaneous equations. So one method of solving these set of simultaneous equations is, what I will do is, I will first take the LCM. Okay, so one method is to find their LCM, and the LCM of the first equation is going to be xy. I will have to multiply 6 by y, so 6y plus 8 gets multiplied with x, so 8x is equal to 4. And on cross multiplication, I get 6y plus 8x is equal to 4xy. So this becomes my first equation in two variables. Now let's solve the second equation. Again, I can take the LCM over here. The LCM is xy, and I have 3y minus 4x as my numerator. So y gets multiplied by 3 and x gets multiplied by 4. This is equal to 0, which implies xy transposes to the other side for multiplication. So I get 3y minus 4x is equal to 0. So this forms my second equation. Now I can take these two equations. Instead of taking equations 1 and 2, okay, let us mark our equations. So this is equation 1 and this is equation 2. Instead of taking equations 1 and 2, I can now consider equations 3 and 4 and solve for x and y. How can I do that? The first thing that I will do is, I will multiply the fourth equation by 2. I am now trying to eliminate x. Okay, so the first equation is 6y plus 8x is equal to 4xy. And the second equation, the fourth equation is getting multiplied by 2. So it becomes 6y minus 4x. 6y minus 8x, I have multiplied the equation by 2, is equal to 0. So now when I add these two equations, 8x minus 8x cancels. So 6y plus 6y becomes 12y is equal to 4xy. Now y can cancel from both sides. So I cancel y from both sides. And 4 and 12 get cancelled by 4. So 4 3s are 12, and therefore I get x equal to 3. Or the other way of looking at this would be, let me erase this and write it one more time. So I have 6x minus 8x equal to 0. Let me write that down. So I have 6y minus 8x equal to 0. Let me add these two equations. So when I add these two equations, 12y becomes equal to 4xy. Now what I'm going to do is, let me leave the x on one side. So my equation is 4xy is equal to 12y. Let me leave x on one side. 4 and y will go down to division. So 12y upon 4y, that becomes 3. And therefore, the value of x in this equation is equal to 3. Now it's time to find the value of y, and finding y is not difficult. I can substitute x equal to 3 in the fourth equation, and I can say 3y minus 4 into 3 is equal to 0, which means 3y is equal to 12 or y is equal to 4, and therefore the solution for x and y is x equals 3 and y equals 4. So definitely LCM is one of the methods which can be used to solve the set of simultaneous equations when x and y are in the denominator. Though you will notice that this is slightly lengthy, but still it is doable. That is what I wanted to prove to you. Now let's find another method of solving for x and y. Let me pause for a minute so that you can just take a look at what was done, and then I will continue with the second method. Okay, let us now continue with the second idea. So the second method would be just to eliminate or rather try to eliminate 1 by x or 1 by y. So what I mean by that is, see, I have minus 4 by y in the second equation and plus 8 by y in the first equation. So let me write the first equation as it is. It is 6 upon x plus 8 upon y is equal to 4. And let me multiply the second equation by 2. So if I multiply the second equation by 2, what I get is 6 upon x minus 4 by y into 2 is minus 8 upon y is equal to 0. And therefore, I can now simply add these two equations. When I add these two equations, plus 8 by y and minus 8 by y cancels. So 6 by x plus 6 by x becomes 12 upon x is equal to 4 plus 0 is equal to 4, which means 12 is equal to 4x, and therefore x is equal to 12 by 4, which equals 3. Therefore, the value of x is equal to 3. Now I can substitute x as 3 in, say, the second equation, and what I get is 3 upon 3 minus 4 upon y is equal to 0, which means 1 minus 4 by y is 0, or 1 is equal to 4 upon y, which means y is equal to 4. So just like I use my substitution method for eliminating the variables, I am using the same substitution method here. Instead of y being in the numerator, I am making sure the y is in the denominator right now. I am just making sure that the coefficient of 1 by y is equal in both the equations, right? So this is how I solve for values of x and y, by making their coefficients equal. So let me again pause for a minute and you can take a look at what was done, and then we will continue. Okay, so in both these methods, you will notice that there was a little bit of effort involved. Now I'm going to show you a method where it gets slightly easier to solve for x and y by the correct substitutions. Okay, so let us see how to use the method of substitution. So in the method of substitution, what we will now do is we will substitute the values of 1 by x and 1 by y. So I can write the first equation as 6 times 1 by x plus 8 times 1 by y is equal to 4. And the second equation is 3 times 1 by x minus 4 times 1 by y is equal to 0, right? So now the substitution that I can make is let 1 by x be equal to a and let 1 by y be equal to b. And therefore, I am substituting this because I notice a 1 by x in both the equations, as well as I notice a 1 by y also in both the equations, right? That is why I am making this particular substitution. So what is the advantage of this substitution? Now what will happen is, since 1 by x is substituted as a, the equation becomes 6a plus 8b is equal to 4. And the second equation becomes 3a, because 1 by x is a, minus 4b is equal to 0. So this is my equation 3 and 4. Suddenly, the variables which appeared in the denominator are now appearing in the numerator. So now I am going to solve for variables a and b, and then I am going to substitute a and b to get x and y. So now x was actually in the denominator, y was also in the denominator. Because of this substitution, I was able to convert the given equations into two equations which are marked 3 and 4, where the variables are now in the numerator. So now let me go ahead and solve for a and b. A and b, therefore, let us label them as my temporary variables. Okay, these are not my original variables. These are just temporary variables. And now let's solve for a and b. I know that I can eliminate b easily. So let me write the third equation as 6a plus 8b is equal to 4. And let me multiply the fourth equation by 2. So because of which I get 6a minus 8b is equal to 0. On adding these two equations, I get 12a is equal to 4, which means a is equal to 4 by 12. Therefore, a is equal to 1 upon 3. Now what is a? A is 1 by x, and 1 by x is equal to 1 by 3, which means x is equal to 3. So once I got my intermittent variable or my temporary variable, I substituted a as 1 by x, and that is how I cross multiplied and I got the value of x as 3. Now if a is equal to 1 by 3, let us substitute a equal to 1 by 3 in, say, the third equation, and let's find the value of b. So 6 times 1 by 3, that's 6a, plus 8b is equal to 4. 6 and 1 by 3 cancels by 3, so 8b is equal to 4 minus 2, which means 8b is equal to 2, and therefore b is equal to 2 by 8, therefore that equals 1 by 4. So because the value of b is 1 by 4, what is b? B is actually 1 upon y. So 1 upon y equals 1 by 4, means this implies y is equal to 4. Therefore, the value of x is 3 and y is equal to 4. So what we did was, in the given equation, we found a pattern which was common to both the equations, and then we went ahead and made the substitution, and then we found our intermittent variables, and after finding those intermittent variables or the temporary variables, we found our original variables. So now let us solve a few questions which demand this particular strategy. Okay, so on the screen we have our next equation. 4 by x plus 5 upon y is equal to 7, and 3 upon x plus 4 upon y is equal to 5. So what I'm now going to do is, I'm going to write this as 4 times 1 by x plus 5 times 1 by y is equal to 7, and 3 times 1 by x plus 4 times 1 by y is equal to 5. Now the substitutions that I'm going to do is, let a be 1 by x and let b be 1 by y. So now what I'm going to do is, I notice this 1 by x part in both the equations. So in place of 1 by x, I'm going to substitute a, and I've noticed 1 by y also in both the equations. So instead of 1 by y, I'm going to substitute b. So the equations that I get is 4a plus 5b is equal to 7, and 3a plus 4b is equal to 5, right? So this is my first equation, this is my second equation. Now by the substitution, these are the equations that I have obtained, right? So let us move them over here. And now let us mark these equations as 3 and 4. So x and y were initially in the denominator. Now I notice that instead of x and y, I have a and b. But the values of a, the variables a and b are in my numerator. So now I am going to eliminate either a or b. The choice is mine. So let us eliminate a. So I am going to multiply the third equation by 3 and the fourth equation by 4. When I multiply the third equation by 3, I get 12a plus 15b is equal to 21. And when I multiply the fourth equation by 4, I get 12a plus 16b is equal to 20, right? And now I go ahead and I subtract these two equations. So when I subtract these two equations, what I get is subtraction, subtraction and subtraction. 15b minus 16b is minus b. 21 minus 20 is 1, which means b is equal to minus 1. But is b my original variable? No, b is just my intermittent variable. So from b is equal to minus 1, let me find the value of y. What was b? If you notice, b actually was 1 by y. So 1 over y is equal to minus 1, which means y is negative 1. So I have found the value of my y now. Now I can substitute the value of b to get a. So substitute b equal to minus 1 in my, say, equation 3, and let's see what I get. 4a plus 5 into minus 1 is equal to 7, which means 4a minus 5 is equal to 7. So a is equal to 3. You can shift the 5 to the right hand side, then divide everything by 4. You get a equal to 3. But is a my original variable? No, a is not my original variable. My original variable is x. So I know that a is equal to 3. But what is a? A is actually, if you take a look at the original substitution, a is 1 by x, which means 1 by x is equal to 3, which implies x equals 1 by 3. Therefore, the value of x is 1 upon 3. So this is how we can solve for the simultaneous equations by substitution, especially when the variables are in the denominator. I am going to pause for a couple of minutes so that you can take a look at what was done, and then I will take up the next question. Okay, so let us now solve this set of simultaneous equations. Again, over here I notice that x and y are in the denominator. So I will again make the substitution. Let 1 upon x. So let 1 upon x be equal to a and 1 upon y equal to b. So the first equation is 1 into 1 by x plus 1 into 1 by y is equal to 8. And the second equation is 4 into 1 by x minus 2 into 1 by y is equal to 2. Therefore, the first equation becomes, because I am substituting 1 by x as a, it becomes 1a, which is a, and 1 by y as b, so it becomes 1 into b, which is b. So a plus b is equal to 8, and this equation becomes 4 into 1 by x. So 1 by x is a, so that is 4a minus 2b is equal to 2, right? So these are the two equations. Let me mark them as equations 3 and 4. So I will always mark my original equations as 1 and 2, and now these equations are the equations 3 and 4. So now let me decide to eliminate either a or b, right? So a plus b is equal to 8. Let me multiply this particular equation by 2, right? So instead of writing a plus b as 8, the equations now become, I am multiplying the third equation by 2. So when the third equation is multiplied by 2, it becomes 2a plus 2b is equal to 8. Is equal to 16. Right? So 2a plus 2b is equal to 16. And 4a, I'm writing the fourth equation as it is. You will notice that I'm interested in eliminating the variable b. So 4a minus 2b is equal to 2. So now let me add the two equations. B gets eliminated. So 6a becomes equal to 18, which means a is equal to 18 divided by 6, which is 3. Therefore, the value of a is 3. But a was not my original variable. My original variable was x. So I know that a is equal to 1 by x. But a is 3. So 3 equals 1 by x, which means x is equal to 1 divided by 3. So the value of the variable x is 1 by 3. Now similarly, from a, I can find b. So what I will do is, I will say substitute the value of a as 3 in the third equation. So I have 3 plus b is equal to 8. That is my third equation, right? This is my third equation. And therefore what I get is, I get b is equal to 5. But b is not my original variable. My original variable is x and y. So what is b? b is actually equal to 1 by y. So 1 by y is equal to 5 means y equals 1 by 5. So the variable x equals 1 by 3 and the variable y equals 1 upon 5. So this is how I solve for the variables x and y using the method of substitution. Again, let me pause for a couple of minutes and then I will continue. Okay, let us now take the next equation. So again in these equations, I observe that x and y are in the denominator. So let me rewrite these equations. I have 2 times 1 by x plus 6 times 1 by y is equal to 13. And similarly, I have 3 times 1 by x plus 4 times 1 by y is equal to 12, right? These are my first two equations. Let me now make an appropriate substitution. So I will say let 1 upon x be equal to a and 1 upon y is equal to b. So the equations that I get are 2a plus 6b, because 1 by x is a and 1 by y is b. See, similarly here 1 by x is a and 1 by y is b. So I get 2a plus 6b is equal to 13 and 3a plus 4b is equal to 12, right? These are my equations 3 and 4. Now my goal is to eliminate a, for example. So let me eliminate a. I am going to multiply the third equation by 3 and the fourth equation by 2. So when I multiply the third equation by 3, I get 6a plus 18b is equal to 39. And when I multiply the fourth equation by 2, I get 6a plus 8b is equal to 24. So when I subtract now, I get 6a minus 6a cancels. So 18b minus 8b is 10b. 10b is equal to 15, which means b is equal to 15 upon 10, and therefore b is equal to 3 upon 2. So this is the value of b that I have got. And now from this I am going to get the value of a, right? So to get the value of a, I will substitute b as 3 upon 2 in, say, equation 4. So when I substitute b as 3 by 2 in the equation 4, what I get is 3a plus 4 times 3 by 2 is equal to 12, which means 3a plus 4 into 3 by 2 is 12 by 2 is 6 is equal to 12, which means 3a is equal to 6 and therefore a is equal to 2, right? So I have got all my intermediate variables now. Now it's time to get my original variables. So I know that a is 2, but a is actually 1 over x. So 1 over x is equal to implies x is equal to half, right? So this is my first variable. Now let's find the second variable. So x is equal to half. Let's now find y. I know that b is equal to 3 by 2. But wait, what was b? b was 1 by y. So 1 by y is 3 by 2, which implies y is equal to 2 by 3. This is my second variable. So I got my intermittent variables as 2 and 3 after substitution, and then I got my final variables as half and 2 by 3. So this is how I use this method of substitution for finding the variables x and y, especially when they are in the denominator. Okay, so let me pause for a couple of minutes and then I will continue with the next question. Okay, let us now take the next equation. Okay, let us now take a close look at the given set of equations. I noticed that earlier I used to have 1 by x and 1 by y, but now I have something different. I see a x by 2 in the denominator and I see a y plus 3, I see a x minus 2 in the denominator and I see a y plus 3 in the denominator. But the good part is I see x minus 2 in both the denominators. So over here I see x minus 2 present in both the denominators, and I see y plus 3 also present in both the denominators. So what I will do is, I will rewrite the first equation as 27 times 1 by x minus 2 plus 31 times 1 by y plus 3 is equal to 87, right? And the second equation is 31 times 1 by x minus 2 plus 27 times 1 upon y plus 3 is equal to 89. Now what I'm going to do is, I notice that 1 by x minus 2 is present in both the equations. So the substitution that I'm going to use is, let a be equal to 1 by x minus 2 and let b equal to 1 by y plus 3. I'm making this substitution because I notice a 1 by x minus 2 in both the equations, okay, and therefore this particular variable or this particular term is going to be replaced by a, right? So that is the substitution that I have done. So a replaces 1 by x minus 2, and let's look at the variable y. You will notice that you have 1 by y plus 3 in both the equations, and this 1 by y plus 3 is now going to be replaced by the variable b, right? So the equations therefore become, so let's mark this as equation 1 and 2. Now I get equations 3 and 4. So it is 27 times 1 by x minus 2 is a. So 27a plus 31b is equal to 87. That is one equation. And the other equation is 31a plus 27b is equal to 89. So I'm just waiting for a couple of seconds for you to really digest what I did. Okay, so now that these two equations are ready in a and b are in the numerator now, I notice that the coefficients are swapped. So I know one technique when the coefficients are swapped. First, I will add the two equations. So when I add the two equations, I get 58a plus 58b is equal to 87 plus 89. So 87 plus 89 is 176. Okay, let me just check if my equations are right. Just a minute. So please excuse me for a mistake in the question. Instead of 87, it should have been 85. And I noticed that this is a mistake because 176 is not perfectly divisible by 58. So I thought that there had to be a mistake here. So this is 85. Let's make that change even over here. This is not 87, it is 85. Okay. So now 85 plus 89 is equal to 174, and 174 is perfectly divisible by 58, right? So now I can divide everything by 58. So I get a plus b is equal to 3. So this was my third equation. This was my fourth equation. Now I got a fifth equation. Let us now subtract these two equations. So 27a plus 31b is equal to 85, and 31a plus 27b is equal to 89. Let us go ahead and subtract these two equations. So when I subtract these two equations, let us see what we get. I subtract and subtract and subtract. 27a minus 31a is minus 4a, and 31b minus 27b is 4b, and 85 minus 89 is minus 4. So dividing everything by 4, I get minus a plus b is equal to minus 1. That's equation 6. So if I went ahead and found the LCM of 27 and 31 to solve equations 3 and 4, it would have been a really tedious job. But because of this nice technique, I was able to get two simple equations in A and B, and solving these equations is really easy. So A plus B is equal to 3 and minus A plus B is equal to minus 1. So if I simplify, I get B is equal to 1 and A is equal to 2. Therefore, I got my intermittent variables. But A and B are just my intermittent variables. They are not my original variables. My original variables are X and Y. So A is equal to 2. A is equal to 2. So because A is equal to 2, what is A? A is 1 by X minus 2, which is equal to 2, which means 2x minus 4 is equal to 1 on cross multiplication, and therefore X is equal to 5 by 2. So the value of X is 5 by 2. At the same time, 1 by B is equal to 1, right? So B is equal to 1. But what is the value of B? B is nothing but 1 by Y plus 3. So 1 by Y plus 3 is equal to 1, which means 1 is equal to Y plus 3, or Y is equal to minus 2. So this is how from the intermittent variables A and B, I was able to obtain the variables X and Y. So again, let me pause for a minute. There are a few things that you should notice here. One difference as compared to the previous questions was, I just don't have a 1 by X and 1 by Y. I have something more than that. So that is something that you should notice. Secondly, I saw that the coefficients were swapped. So adding the two equations and subtracting the two equations, this was another powerful technique that was used here. Okay, so I want you to take a look at all those techniques in this particular problem. So let me pause again for a couple of minutes. Okay, let me take one more equation now. Let us now consider this set of simultaneous equations. I notice that both the equations have x plus y in the denominator as well as x minus y in the denominator. So I am going to write the first equation as 16 times 1 upon x plus y plus 2 times 1 upon x minus y is equal to 1, and the second equation is 8 times 1 upon x plus y minus 12 times 1 upon x minus y is equal to 7, right? So this is my first equation and this is my second equation. Now I am going to substitute. 1 by x plus y as A and 1 by x minus y as B. So what I get is 16A plus 2B is equal to 1 and 8A minus 12B is equal to 7. So this is my third and fourth equation. So now what I'm going to do is I am going to solve for the variables A and B first. Why did I make this substitution? I made this substitution because I saw 1 by x plus y in both the equations, and I saw 1 by x minus y also in both the equations, and that is why this substitution was really helpful. Okay, so 1 by x plus y was substituted as A, so I got 16A and 8A, and 1 by x minus y was substituted as B, so this became 2B and negative 12B. So now I'm going to I'm going to eliminate either A or B and find A and B first. So let us decide to eliminate say A. So I'm going to keep the third equation as it is. Third equation is 16A plus 2B is equal to 1. And I'm going to multiply the fourth equation by 2. So this becomes 16A minus 24B is equal to 14. Let me subtract these two equations. So now when I subtract, I know that the signs of the second row get flipped. So 16A minus 16A cancels. 2B plus 24B is 26B is equal to 1 by 1 minus 14 is minus 13, which means B is equal to minus half. Now I can substitute B as minus half and get the value of A. Let us substitute B as minus half in the third equation, and what I get is 16A plus 2 into minus half is equal to 1. So 16A minus 1 is equal to 1 because 2 and 2 cancel, which means 16A equals 2 or A equals 2 upon 16, which is equal to 1 by 8. So the value of the variable A is 1 by 8 and the value of the variable B is minus half. But A and B were not my original variables. My original variables were X and Y. So A is equal to 1 by 8, but A is basically 1 by X plus Y. So 1 by X plus Y is equal to 1 by 8. Cross multiplying, I get X plus Y is equal to 8. That is my next equation. Similarly, B is equal to minus half, but B actually was 1 by X minus Y, which was equal to minus half. Cross multiplying, I get Y minus X, because when X minus Y is multiplied by minus 1, it becomes Y minus X is equal to 2. This is my second equation. So now this is equation number 5 and 6. From 5 and 6, I get Y is equal to 5 and X is equal to 3. These are the values of X and Y. So again, the key idea in substitution is to find the same pattern that exists in both the equations and to find the right substitution, to find the intermittent variables and then find the original variables. Okay, so let us take some more questions now based on substitution. So let's consider the equations that are given on the board right now. Again, I notice that there is a 1 by X minus Y in both the equations, and there is a 1 by X plus Y also in both the equations. So what I'm going to do now is, I will rewrite this as 4 times 1 by X minus Y plus 1 times 1 by X plus Y is equal to 3. Okay. And the second equation is 2 times 1 upon X minus Y minus 3 times 1 by X plus Y is equal to 5. So what I can now do is, I see that I have 1 by X minus Y in both the equations, right? I have 1 by X minus Y in both the equations, and similarly I also have 1 by X plus Y also in both the equations, if you notice. Yeah. So 1 by X plus Y is also there in both the equations. So that is going to be my second substitution. So the first substitution will be let A be 1 by X minus Y and let B be 1 by X plus Y. So now what I will do is, I will take this first equation. First equation becomes 4A plus B is equal to 3. And the second equation, so let us mark this as equations 1 and 2. Second equation becomes 2A minus 3B is equal to 5. These are my third and fourth equation. Now the third equation should be multiplied by 3. So third equation multiplied by 3 gives me 12a plus 3b is equal to 9. And the fourth equation is 2a minus 3b is equal to 5. So when I add these two, what happens? 14a, 3b negative 3b cancels, is equal to 9 plus 5 is also 14, which means a equals 1. Now because a is equal to 1, I can substitute. So substitute a equals 1 in, say, the third equation. So 4 times 1 plus b is equal to 3, which means b is 3 minus 4, or b is equal to minus 1, right? b equals minus 1. So I got my intermittent variables, which are a and b. Okay. And now it's time to go ahead and find my original variables. So what is a? A was equal to 1, which means 1 by x minus y was equal to 1, which means x minus y is 1. This is my fifth equation, right? Similarly, b is equal to minus 1, b equals minus 1, which means 1 by x plus y is minus 1, which means x plus y is equal to minus 1. This is my sixth equation. Now I can definitely go ahead and solve for x and y. If I add the two equations, I will get x equal to minus 1, x equal to minus 1, x is equal to 0, that is what I will get, and I will get y equal to minus 1. Therefore, this is the solution for x and y. So I am going to pause again for a couple of minutes for you to check the solution, and then I will continue. So I hope you understood the idea behind the substitutions. Let me now give you a few questions to solve for your classwork and homework, and then we can definitely check the answers. Okay. So I'm now going to post a few questions for you people to solve. Okay, so these are a few questions for you to solve. I will just pause the video for a minute so that you can take photos if you want. And this is okay. So I hope you were able to understand the principles behind the right substitutions for solving the variables, especially when they are in the denominator.